Okay, on Algebra 1, Chapter 1, Section 7, we're going to be working on distributing as well as combining like terms. To start out, we're going to talk about the distributive property. Distributive property is a shortcut that allows us to bypass the order of operations. So for when something needs to be distributed, what you'll see is a number attached to a grouping symbol. So for example, it'll be number 2 attached to the parentheses. That means you distribute 2 to every term on the inside of the parentheses, and we'll talk about what terms are. When you distribute, you multiply that number with every term on the inside. So here's the distributive property in action. Here's a problem, order of operations, very simple. First you subtract the parentheses, and then you multiply 3 times -8. And you get your answer. Now let's look at it using the distributive property. Same problem, but this time instead of simplifying in the parentheses, we're going to distribute the 3. There's 2 terms on the inside, 4 and 12. So the 3 gets distributed by multiplying the 4 and the 12. 3 times 4 and 3 times -12, or sorry, 3 times 12, with a minus sign that was in the parentheses in between the 2 terms. Now we multiply each new product is 12 and minus and 36. Then we subtract 12 minus 36, -24. Notice they stay the same. So here's another example of the distributive property in action. If we want to multiply 2 big numbers or a double digit with a triple digit number, what we can do is we can take one of the numbers if they're really close to something that's easy to work with, like 305 is close to 300. We can split 305 into 2 different sums, or a sum of 2 different numbers, 300 plus 5, and then distribute the 15. Think about what 15 times 3 is, which is 4,500, and 15 times 5 is, which is 75. When we multiply those together, it should be 4,500. Whoops. And then when we combine them, it's 47, or 45. 75. Ooh. And we can do that mentally in our head if we have practice. So in order to distribute, sometimes we'll have variables, and these are binomials because there's this number with a variable and then just this number by itself. It comes in handy because you can't simplify in the parentheses, but what you can do is distribute. You don't have to know what x is. So we're going to distribute that 2 to the 5x and the 2 to the 3. We pass it along to both. We distribute it to both. And then we multiply them out. 2 times 5x is 10x, and 2 times 3 is 6. Now we can't go any further at this point unless we know what x is and what we want to plug in for x, but right now that's all we care about. So let's simplify 3b minus 2 times the 1/3. Numbers can be distributed from the right as well. Notice this is the binomial because it has 2 terms and this one has 1. So we're going to take that 1/3 and we're going to distribute it to the 2 and the 3b. Now the thing that started with 3b is going to still be 3b in the front. It's going to be times 1/3, and then the 2 is going to be second. It's going to be times 1/3. We multiply those out. 3b times 1/3 is 1b. 2 times 1/3 is 2/3. Remember, when you're multiplying fractions, you always want to write whole numbers as fractions by putting 1 on the bottom. And if you wanted to multiply by 1/3, you'd have that fraction set up like that. 2 times 1/3 would be 2 over 1 times 1 over 3. So I can cross simplify here, and I'm just left with 1 times 1, which is 1, and 2 over 3. So that's where I got the 1b and the 2/3. So you try. I want you to simplify 0.4 plus 1.1c times 3. Is it A, 4.5c, B, 1.2 plus 3.3c, C, 0.44c plus 1.2, or D, 0.4 plus 3.3c? For more problems like that, you're on page 50, numbers 15 through 26. Next example, we're going to be distributing with a negative sign, like negative quantity 6x plus 4. What you want to do is imagine there's an invisible 1 between the negative sign and the parentheses. So instead of this, it's going to be this. Imagine there's a 1 there. Now all you're doing is distributing -1. So the -1 goes to the 6x, the -1 goes to the 4, And we're left with negative 1 times 6x, which is 6x, negative 1 times 4, which is 4. Okay, you're up. Make sure to put a 1 after this negative sign. What's negative parentheses 7 minus 5b? Is it A, 7 minus 5b? Is it B, negative 7 minus 5b? Is it C, negative 7 plus 5b? Or is it D, 2b? Okay, now what we're going to do is we're going to move on to combining like terms. Now that we know how to distribute, we can begin working on another shortcut called combining like terms. In your book, in Chapter 1, Section 7, there are 4 terms that I need you to look up there, and I need you to copy this table down. The terms are the vocabulary: term, constant, coefficient, and like terms. These things will probably be on your test, so it's important to have them in your notes ready to copy down. Now, looking at like terms, here's some examples. Like terms are things you can add or subtract. So 3x and negative 2x, you can add those together. Not like terms are when there's different variables, like 8x and 7y. You can't add those together. Like terms can be negative 5x to the power of 2 and 9x to the power of 2. They are the same variable with the same power. But 5y and 2y squared are not like terms because this one doesn't have a power of 2 and this one does. If you have multiple variables like xy and negative xy, those are like terms, just as long as they have the same variable. 4y and 5xy are not like terms because this one doesn't have the x. Now, xy and yx are also like terms because well, we haven't got to this yet, but there's a thing called the commutative property that says that y times x is the same thing as x times y. So those are actually the same thing. And so it doesn't really matter the order that they're in. You could have x and then y, you could have y then x, or if you had ABC, you could have BAC. It doesn't matter, but just as long as they're the same variables, they're with the same powers. So I want you to come up with 2 like terms and 2 not like terms, and put them in your notes in these columns. Moving on though, we're going to look at combining like terms using the distributive property. We're going to simplify. For example, 3x squared plus 5x squared. Notice how each of them has an x squared. It's as if we had distributed that x squared. And so what we can do is we can actually undistribute. And when we undistribute, we're basically taking these x squareds and we're pulling them back out. And when we pull them back out, we put them outside of a parentheses, and what's left over is on the inside, the 3 and the 5. So now the 3 and the 5 are basically like terms. You can add them together. You got 8x squared. So again, negative 5c plus c, if there's just a variable by itself, make sure that you put a 1, because that means that there's one of those c's. So now it's negative 5 plus 1c, negative 5c plus 1c. So we're going to undistribute, or we'll put a 1 in front, and then we're going to undistribute, and that means we're going to take out the c's and have what's left over on the inside of the parentheses, combine like terms on the inside, and we get negative 4, because negative 5 plus 1 is negative 4. So I want you to try. Simplify negative 9w squared minus 3w squared. The answer is either A, negative 12w squared, B, negative 6w squared, C, negative 12w to the 4th, that should be negative 12, or D, 6w squared. For more problems that are similar, please do page 50, numbers 35 through 42 all. And that's it. Good luck.